Good morning. This is Dr. Venkat Narayana, Department of Chemistry, GTM University, Hyderabad. Today, we would like to give seminar on engineering materials. These engineering materials are broadly divided into 4 types: refractories, glass, ceramics, cement. But we are more concentrated on refractories. And what are the topics we are going to cover in the refractories? We are described in the next slide. Objectives of refractories, characteristics of a good refractories, classification of refractories, properties of refractories, manufacturing of refractories. So next slide is, what are the objectives of refractories? The material withstand at high temperature without softening or undergoing any deformation in shape, to resist loss of heat and resistant to abrasion. The next one is characteristics of a good refractories. Not to fuse at the operating temperature, should not undergo any change in physical, chemical, and mechanical properties at high temperatures. Must be chemically inert towards the corrosive action of molten metals, slags, and gases produced in the furnace. Be capable of retaining its original form without cracking and splitting when subjected to sudden temperature changes. Be strong enough to bear the charge load at the working temperature. Resist the abrading action by molten metal or slag. Should not undergo contraction and expansion. Classification of the refractories. This classification is divided based on the chemical composition. The first one is the acid refractories. The second one is the basic refractories. Third one is the neutral refractories. Generally, acid refractories which readily combines with bases. The best examples are silicon dioxide, aluminum oxide, and fire clay refractories. So in these refractories, 92% silicon dioxide is the main composition. Next, coming into the basic refractories, which consist mainly the metallic oxides, which resist the action of bases. For example, calcium oxide and magnesium oxide, these two are coming from magnesite and dolomite. And the magnesium oxide is the major composition at around 60%. Neutral refractories, which does not combine either with acids nor bases. Best examples are weakly acid or weakly basic, pure aluminum, chromite, zirconia, carbon. The main composition is 30% aluminum oxide. Properties of refractories. Here we are going to describe the main 6 important of refractories properties. The first one is refractiveness, strength or refractiveness under load. The third one is the dimension stability. The fourth one is the chemical inertness. Fifth one is the porosity. And the sixth one is the thermal spanning. Now we are going to discuss each and every one in detail. Refractiveness. Refractiveness is nothing but ability of a material to withstand the heat without appreciable softening or deformation under given service conditions. It's measured as a softening or melting temperature. Softening temperature must higher than the furnace temperature or operating temperature. This refractiveness generally determined by the standard pyrometric cone equivalent or Sager cone test. How to measure the refractiveness? The refractory materials cones are molded into a small pyramid shape that is 38 mm high and have a triangular base with a 19 mm long sides. They melt or fuse at definite temperatures when heated under standard conditions of 10 centigrades per minute. The temperature at which the fusion or softening of the test cone occurs is indicated by its apex touching the base. The PC value of the refractor is the number of standard cone which fuse along with the test cone. The next property is strength or refractiveness under load. It is simply represented by RUL. Refractory materials must possess high mechanical strength even at operating temperatures to bear the maximum possible load without breaking. What is the RUL test? It is a measure of deformation under load. The test specimen rectangular in shape with a base area of 5 cm square and a height 75 cm. Test load is 1.75 kg per centimeter square or 3.75 kg per centimeter square. Heating at a standard rate of 10 centigrades per minute. Temperature at which 10% deformation occurs is RUL. The third property is dimensional stability. Dimensional stability is nothing but the measure of ability of a refractory material to resist any change in the volume during working conditions. Dimensional changes could be reversible or irreversible. The irreversible or permanent changes may be due to contraction or expansion of brick material. Phase transformations may also occur during heating and cooling. Reversible change occur in most bricks at a temperature less than 750 centigrades. Chemical inertness. A good refractory must be chemically inert. The chemically inactive in use does not easily form fusible products with slags, fuel ashes, furnace gases, and so on. Acidic refractories are affected by basic slag. Basic refractories are affected by acidic slag. Neutral refractories are not affected by both acids and bases. Porosity increases chemically activity. The next one is the porosity. It is a measure of number of pores incorporated during the manufacturing of refractory bricks. A good refractory should have low porosity. It is expressed as the ratio of volume of open pores to total refractory volume. Low porosity results in less penetration of molten material and a high strength of bricks. The amount of pores present in the refractory materials is represented by P is equal to W minus D by W minus A into 100, where W is equal to weight of saturated specimen in air, D is equal to weight of dry specimen in air, A is equal to weight of saturated specimen submerging in water. If porosity decreases, what are the advantages in refractories? The chemical resistance should be increases, the strength also will be increases, the thermal conductivity also should be increases, and that refractory materials highly resistant to thermal spalling. If porosity increases in bricks, what happens? The abrasion resistance should be decreases, the corrosion resistance also should be decreases. Next law property is thermal spalling. Thermal spalling is nothing but breaking, cracking, peeling off, fracturing of refractory material under the influence of high temperature. It is due to rapid changes in temperature cause uneven expansion and contraction of refractory materials. Effects of the thermal spalling. Slag penetration will take place, and the corrosion takes place very severely. Abrasion also takes place very severely. How to control thermal spalling or how to reduce? By using materials with a low efficient of expansion and avoiding sudden temperature flocculation. For example, addition of alumina in small quantities decreases expansion to a large extent. Using high porosity bricks, using good thermally conductivity bricks. Thank you.